Hi guys, welcome to Learn Electronics Repair. This is a vintage AT power supply. So it's not the same size as a normal or regular AT power supply made by Delta. I think these guys even may still be going. They seem to make a lot of power supplies. This is from a computer I found at the car boot sale, which is a 286, an ATPC from 1988. So that's basically the age of this power supply. The computer's working. I used a standard AT power supply. The connector, although it looks slightly different, is actually the same. So using a standard AT power supply, the computer's working. I did check first. Yes, the pinout is actually the same. But it'd be nice to repair this one. Then I can get the machine back into its original condition. I mean, this thing really is almost a museum piece. A lot of you guys were interested and asked, so yeah, let's have a look at this. There's definitely two ways of fixing this. Let's get the top off and see what we have inside it. And this is what we have. I knew the cooling fan had literally fell inside this thing. It's just lying on the PCB now. And there is our power supply, rather dusty. Nothing initially looks like it's exploded, although it's possible something has somewhere in there. So there's two ways we could fix this really. One is to repair the power supply. The other one would be to take something like a standard AT power supply. I have a few of these from old retro machines I've found from time to time. Look to see if it has a suitable power rating compared to this original one, which I think is a bit worn off, but still. And literally take the PCB and fan out of here and fit it into here. So use the original sockets and the switch which goes to a rod on the front of the machine. Find some way to mount the PCB inside here. Probably use this fan back into the top of it and connect it to wherever the fan in that one connects to. And what you've really got then is kind of like a Frankenstein power supply, which looks externally like the old one, but it's a slightly new one inside. So that's the other option. And to be quite honest, if I can't fix this for any reason, I will do that as a last resort, so I can have this machine looking as much like the original as possible. But I'm sure you will agree it'd be much nicer to try and fix this. The fault with this when I tried it is that I connected a power lead from my current limiting light bulb. The light bulb came bright and then went dimmer. So the capacitors inside here, they definitely charged up. Power got into it, but it didn't start, it didn't work. Because I know power got as far as these capacitors, then we can say the fuse is okay, or the input wiring is okay. The fault is somewhere else. I can also, for that matter, say that the main switch is okay, because that switch has to be closed for the power to get as far as the capacitors. This is a bit simpler than an ATX power supply, but in a way it's also similar. The main difference really between this and an ATX is an ATX would have a separate standby power supply here somewhere that drives the standby, and then when you press the soft start switch, it starts the main power supply. Because of that, with an ATX, quite often the controller chip which is driving the switch mode power supply is on the low voltage side, not powered by the 5 volt standby, but the same standby transformer will be generating another voltage, sort of 12 to 20 volts, around 16 is quite common, and that voltage is powering parts of the circuit on the low voltage side, which then drive the transistors on the high voltage side, the switching power supply. Because of that, you will find there is an opto isolator between the low voltage and high voltage side, and also usually a third transformer. So we have the main switching one, the standby one, and the third one, the primary, is on the low voltage side, and the switch mode controller, the pulse width modulator, drives the main switching transistor via that transformer, primary to secondary, so it's isolated. So that's the basic layout of an ATX. This is a bit different. It has just a main switch, it's either on or it's off. This transformer generates the low voltages, plus and minus 12, plus and minus 5. So on the low voltage side, we will find we have rectifiers, probably these here, maybe some more under there as well. I can see something else here that could be a rectifier or a regulator. But the low voltage supply is not there until the thing is running, so whatever's controlling the power supply, the switch mode, must be on the high voltage side. Okay, so looking on the high voltage side, well, I have a resistor that's falling over and feels loose, actually. That I'm suspicious of that to start with, but it looks like this is the switching transistor, and it looks like this only has one, whereas normally in ATX it has two. Okay, see another fuse down there, as well as the fuse down here. This one I'm sure it is intact, or at least one of them I'm sure is intact. I don't know what the other one's doing exactly. Looks like this transistor is driving the primary of this, and then, as I said, the secondaries are all this side. So the fault on this could be a number of things. Because it draws power, so the current limiter lights up then goes dim, tells me, hey, I haven't got a short on this side of it, okay? Otherwise the light would just come on full brightness. I probably don't have a short on this side either. Otherwise, you'd expect the light to stay on fairly bright if it's running. I could have a short on this low voltage side, which is preventing it from running. That's possible. Or I could have some other issue going on here. So I need to figure out what drives this. In other words, what drives that. That has three legs. It looks like a transistor, but it could be something else. What I don't see at the moment is any sort of IC or controller. This could be some sort of self-oscillating thing. What I am, as I say, a bit worried about is this thing. Like you can see, it just waggles around. And what's this down here? Well, I think what I'll do is I'll actually get the PCB out of here so we can have a closer look. We have two plugs going down here, which I'm assuming are mains voltage. I just need to take these zip ties off here so I can have a quick look just to see how this is connected to there. The fact they are plugged in makes it easy to take the board out. So this one is this is the mains out going to your monitor normally, so that's mains out. This is mains in here, so that comes in via the switch. So this is your mains input, and that is a mains output. In fact, now it says there outlet. I can see it marked on the PCB. Okay, let's unplug these then. Let's get this board out, and then let's see what we have. I have the PCB loose. It's unlikely there's any voltage in these large capacitors. It's been sitting here over the weekend, but better safe than sorry. Okay, there is nothing there. Oh, that's the wrong place. Yeah, there's nothing there. And there's nothing there, so it's safe enough to handle. And here it is. If we just have a quick look underneath, so straight away we can see the big divide between the low voltage side and the high voltage side. Okay, that's this big gap down here. I don't see any opto-isolator or any sort of feedback between the two. Ah, there's like a little transformer thing here. Okay. And that is mounted across the two halves. So this is basically doing what an opto-isolator would do, but it's using galvanic isolation. So there is a feedback between the two sides. There's a chip here. This is an LM339. This is quad comparator, I think. Just have a quick look at that number. Yes, and I'm correct. It's a quad comparator, quad single supply comparators. Designed in level detection, low level sensing. So basically what this has is 4 effectively operational amplifiers in here, but they're optimized to be used as comparators, and it will take on each one a reference input and another input and compare the two. So this will be monitoring the output rails, plus and minus 12, plus and minus 5 probably, and then driving something, or rather sending a signal to something on the high voltage side. I don't see any other ICs on this side. I see a Zener diode. That'll be a reference, probably one of the inputs to this comparator. It may actually only be monitoring one of the voltage rails or two. It might not actually be monitoring all 4. And then just using the principle that if that voltage rail is correct, the other ones will be correct, just by the fact we have the different ratios of turns on the secondaries here. Okay. We can see this other thing down here now. What is this? Yeah, this is a 12 volt voltage regulator, 7912. That's a negative regulator, so that's your minus 12. Okay, something else down here, can't easily see it. What's this thing? Could be a 7905 minus 5 maybe. Okay, can't actually see it from that angle. Not easily at least. Could be something like that. Voltage regulator. And now to the high voltage side. So we know we have feedback between the two sides. This is this resistor I was talking about. We can see in actual fact that is broken. So this is probably what's wrong with our power supply in actual fact. Transistor. Looks like another one of these little drivers. Could be an inductor, that one. No, it says T3, so probably a transformer again. And the main switching transistor. I don't see any other semiconductors particularly. So I would suspect this is some sort of self-oscillating circuit, and either the frequency or the duty cycle is being affected by whatever's coming out of this transformer, and this is being driven by effectively detecting whatever voltage is on the low voltage side. What's this thing? TL431. Yeah, voltage reference for this transformer, that one. Okay. Little adjustment probably sets the output voltage, and all this stuff is on the low voltage side. Yeah, low voltage side. So we have a good idea of how this actually works. Now it's fairly simple in actual fact. It shouldn't be too difficult to diagnose. I'd say this is a transistor which is driving that transformer, all involved with this. Oh, inductor. But this is a problem. Right, let's have a look where this goes in and what it's soldered to. Well, there's a few SMDs on this side. No, I don't think even any transistors on here. Just diodes, resistors and such like. Okay. That big resistor comes here. I think it's actually mounted between these 2 points. There and there. Looks like it. Okay, let me try and desolder this and have a look. Yeah, this is a broken soldered joint actually. I was just going to desolder it. Soldering iron isn't up to temperature anyway, but let's have a closer look. Yeah, look, I'm moving the resistor and it's moving that. Can you see it? In fact, it's broken both sides. I think I'll unsolder it, put it in straight and then resolder it anyway. Okay. And it fell out of the board. I mean, literally it fell out of the board. Bit of black gunk. A little bit of the outer ceramic fell off it. We can test this. We can see where it came from. So that black gunk is glue, I would say. Okay, I'm pretty sure I'm going to clean that off actually. Don't like the look of it. Very brittle. Okay. And that probably is our fault. I think it's worthwhile just checking this transistor that's right next to there, maybe connected to it. Could conceivably have been damaged in some way. Can we see a port number on that one? Focus, there we go, D1247. So yeah, let's just check that thing. Simply because of its proximity to that resistor. Yeah, it's here. Doesn't look like that actually did directly go to there, but why not test it? If I see semiconductor junctions where I would expect, I'll probably say it's okay. If I don't, then I can always just take it out and have a look. So let's see, not sure which is going to be the base. Diode junction. And that reads lower. Well, I can't get a conclusive reading on this one. I sort of see that. That looks like probably a low value resistor across there. So ohms range, let's have a look. Yeah, 300 ohms. 300 ohms, it'll be the same both ways. Probably base to emitter or base to ground if the emitter's to the ground. So that's stopping me getting a sensible reading of this one. Okay. So I'll take that out and just check it anyway. It's quite likely that these diodes around here are also causing that to give strange readings, and it's not directly connected to this, but hey, if I can't say definitely it's good, I'll just take it out. Let's have a quick look at this resistor first. So this is a 18 ohm 10 watt resistor. Let's see. I think it reads okay, just need to get a good connection to it. 18 ohms. I eventually got a connection to it, okay, 18 ohms. So that's okay. We'll have a look at this transistor while we're here, then we'll put this back together. And then let's see if it actually works. Easiest way with this one, probably just warm all the legs at the same time and just pull it out the board. Okay. Okay. Yeah, that's nice and clean. It's clearly marked which way round it goes, but I did look first anyway. Yeah. I suspect this probably is alright. Let's see. Yeah. It is alright. Okay. Let's solder these back in and then see if it works. If it does, I'll use a little bit of araldite or something just to hold this down to stop it falling over again. And yeah, that might well fix it. This one's a little bit tricky. There's obviously a bit of corrosion on the legs to this resistor. Doesn't quite want to make a good soldered joint. Sure, I can get it to do it. Come on. Let's just try that. So from here to here, well, in fact we can measure from there to there, 18 ohms. Yeah. My meter doesn't be quite zeroing. And the resistor's also quite warm from soldering as well, so that usually makes them read a little bit higher. But yeah, pretty sure I've got a connection there. Okay. Yeah, in fact, look, it's going down a little bit as it cools. That's normal. One last thing while I'm here, let's just have a quick look for any shorts on the output. Might as well. Nothing to lose. So ohms range. These black leads are all ground, so any of those. I'm expecting to find a resistor on the output of this just to help the power supply stabilise. 31 ohms. This is also the 5 volts, and then we have the -5, I think that one is. Yeah, 600k roughly. And then we have the plus and minus 12. It's quite high, that one. And that one quite a bit lower, but they all look okay, so there's no shorts. Let's try this now and see if it works. Oh, actually there's one thing I didn't check, and that's both fuses. I'm thinking this one here is now probably on the output. It reads okay, and the other one, yeah, it reads okay, but we pretty much knew that because we could see power was getting into this just looking at the light bulb. Right, we're ready to go. I don't need to connect this one because this is just the power to the outlet, so that's not relevant to the point of testing it. We have the light bulb up there. I have my multimeter connected to the 5 volts output. The light bulb should stop anything too dramatic from happening, but you know, let's get it all into shot. There you go. On off switch. It's a bit sticky actually, but that's on. Right, what's this going to do? Well, we have 5 volts. Yeah, and the light bulb actually, I didn't see it do anything. Well, I can say the reason the light bulb didn't do anything, I forgot to switch it into limit. There's a switch on it on direct. So if I had done something bad, this could have gone quite spectacular. Yeah, you guys would have loved that, I guess. But it didn't. So we know it works. We have 5 volts there. Let's just check the other rails while we're here. So this is the -5. That's close enough. -12, it's spot on. +12, very close. So all the outputs are reading correctly. I'll just let the capacitors discharge in this. It shouldn't take too long because the power supply actually does run. And then let's just put it together and let's see if the PC boots up with this in it now. It's mostly back together. I didn't connect the floppy drive power. Actually, I should have done, but I made the mistake of putting the power supply in first and I can't reach the damn connector. That actually might stop it from booting, have the interface connected but not the power. Okay, let's find out. So, power on. This on-off switch is a little bit sticky still. It does operate, it's like a little bit lazy, but fair enough. You can see the screen there. What's it do? Well, it doesn't bleep. And actually the fan isn't rotating. I have that plugged in. Oh. That surprised me. Huh. So now, oh, and then the fan did spin. Let me just connect this thing up. I'm a bit unhappy that I have the interface connected but not the power. Okay, disconnect this a minute, or I'll just get to it. No, actually, leave that in there. This is the easy one to do. Okay, I've just balanced the power supply on here actually, so it can't fall in. Everything is plugged in, so let's have another go. No, it definitely doesn't want to work from this power supply. Let me just try my good one again. Actually, I'll just check the voltage coming out of this. Did I do something silly when I reassembled it? We'll see. Okay. Yeah, it's not. Put the switch on. Well, it powers up now. The fan spins. Must be something when I connect it to the computer that's loading this and the fan doesn't spin. Is it this hard drive? Let's see. I'll disconnect the hard drive. Yeah, thinking I might get the wire in this way, but I can't. Never mind. Where's this one go to? Yeah, this is both floppies, so I'll disconnect that. Okay. Now what happens? Let's see. Oh, it bleeped and it's running. And the monitor came on. I'll just do that again so you can actually see we do get a picture. Okay. Blue light. Yeah. You'll get some, there you can see it now. Keyboard error. Probably in the glare of it, but there you go. Okay. So power supply is working, machine boots. Let me connect the power to the floppies and then to the hard drive. So initially it's just to the 5 1/4 inch floppy. What does it do? Runs and boots. Okay, now we'll put the 3 1/2 inch floppy on. Connected. Bleep. Blue light on. So that's okay. I'll now reattach the floppy drive interface, and if it then wants to boot, we'll put the hard drive back on. So there's the floppy drive interface back on. What does it do? Yeah, bleep. boots. Okay. And then the hard drive. We'll go power first, just power. Okay. Switch on. Boots. Yeah. Writing on the screen. And then lastly, we'll put the interface back on. It's key that only go one way. Last test. Power, fan running, bleeps, boots, light on the monitor. Yeah, and writing on the screen. Okay, so I can only assume either the power switch wasn't just pushing in right. That wouldn't surprise me, it's a bit sticky. I think I'll just give that a clean. Or it's possible when I connected this one under here, I had it shoved off to one side slightly, so either the 12 or the 5 was shorting to ground. That would stop it from running. Not sure, it's very awkward to get down there. Okay, so I think we can call that repair a success. And the next thing will be to see if we can get this hard drive working. So guys, you know what I'm going to do. I'm going to ask you. I've heard in the comments already about trying to spin this thing. I guess I need to take this plate off it. Yeah, there's the hard drive in all its glory. I can see it has a stepper motor. I'm guessing this is for the heads. I don't want to move that thing around at all. Okay, but it has a stepper motor. The spindle, well, if I need to get to it, I guess it's underneath this PCB here. So that's the next thing. Can we get this hard drive working? That's another little video. So guys, comments, what would you do? Do you think we can fix this? Do you think it's worth trying? And if so, how should we try it? Okay, hope you enjoyed that. We're getting somewhere with this machine now at least. And I look forward to seeing you all soon on another Wayne Electronics repair video. Ciao for now, guys.